Hi, I'm Robert Stefanic,
And I'm Alex Grycuk.
and we did our final presentation on Chicago Public High School data. So we specifically wanted to look at Chicago Public Schools and take a look at the data that we can pull from them, specifically in relation to ACT scores. So what our program does is it takes, we got the data from the City of Chicago website, and we look at patterns within the Chicago public school system to see if there was a relationship between ACT scores and attendance, support systems that are given to kids at schools, the relationship between ACT scores and the area that the school's in, and schools that are on academic probation and their test scores. Chicago public schools are pretty notorious for having poor test scores, and we were interested in the factors that contributed to having poor test scores. So we wanted to look if there was maybe something between the location within the city that contributed to poor test scores, support that kids got, or just their attendance.
All right, so moving on to the actual program. Here we have one main program, and we run it by calling CPS data and the file name. This is our data file name, the text file. And we have 4 different functions. And
The first function is the attendance versus the ACT scores. So it takes a look at, it compares the attendance and sees if there's a relationship between higher attendance and higher ACT scores or not. The second one analyzes the schools that are on probation and their ACT scores. That schools that are on academic probation, maybe they have lower ACT scores. We looked at the supportive environment that kids are given in their schools versus their performance levels within that school. And we also added a function that you could search by a zip code to see the average ACT score given in that zip code.
all right, so the first function pulls up a graph, a scatter plot of ACT scores versus our attendance, average percentage of attendance. So as you see, like as you go up and to the right, this means a higher attendance, right? And a higher corresponds with a higher ACT score. So very like at the top of our graph, you can see the highest ACT scores culminate here. And what we did is we made the limits of our x-axis 50 to 100% because there weren't actually any schools that had under 50% attendance, even though you can see like someone here has like 57% attendance, which is absolutely terrible. And we have the lowest ACT scores also culminated around the 15 area, 14 area. That's really the lowest they went. So that's where we made our limits. And we chose a scatter plot because this like it shows the how many schools are actually in this lower level, this lower bracket of like bad learning. And you could see like a very small amount, like maybe 10-15 schools are actually getting out of this range, like above 20 ACT scores. And moving on to our next function, we have school probation versus ACT scores. And here we only have 2 bars, pretty simple graph. Either they're off probation or on probation, and you can see very easily when schools are off probation that they average like 3 points higher than schools that are on probation. And this is just a reflection of how the schools are trying to help the students themselves, like whether their teaching is up to standards and why they're on probation, what effect probation has on, or what probation reflects of the school. And next function is the supportive environment. Now this one we have a little submenu which goes through each level of support that was listed, because we only had 4 different levels of support that were listed within the data set. So we start off with weak, and here you can see the performance is all far below average and below average. Now this isn't like necessarily everybody's scores, but it's not reflective of everybody's scores, but it's the average of 92 schools. So all the average scores in each of the 92 schools were either below average or far below average. Now if we go through this data set and look at schools from strong supportive environment, we see a much more even distribution. We see less far below average and far above average, which makes sense in a bell curve. We see like medium above average and average. It's still not great because we have this huge below average area. And we can see the contrast with some place that is very strong, like very strong support. All are far above average. And this, you can see the correspondence with average too. Like average, you see that above average and average are far outweighed by far below average and below average. And going to our last function, search zip code. This is a nifty little function. You search a zip code. For the default zip code is 60617. You just rip it in and you get an average ACT score for that area. Rob, anything else?
No, that pretty much sums it up.
All right, I'm gonna go through a couple of things, a couple of nuances within our code. So first is gonna be the pie charts. So we're gonna go into the pie charts. Now the pie charts are pretty cool because you can label them and they give you a nice visual, right? So if I pull up the pie charts right now, third function. Yep, third function. You can see how they're split up. Here we have 4 different strings, right, that correspond with each pie chart, and we label each one of them. And you can see we have just another menu operation here, and really fun to label these. Probably the most enjoyable part of this project right now was labeling these and seeing the outcome, because it really, like, through a bar graph you might not be able to see as much as we saw, like the effects. And also probation and scores. This is another function that was really cool because we got to mess with the bar graphs. Here we could have messed with face color, which was the face color of the bars. I'll pull it up again. Face color. So you see we could have changed the face color of the bars, also the edge color and the line width on the ends of the bars. So that was an extra facet to bars. And that pretty much wraps it up. That's all we had that was really nuanced, really different from what we learned in instruction. So that's pretty much it. Rob, any closing words? No? All right. Well, I guess we're done.